So like we mentioned, this negative sign is about keeping this left side, which is going to be negative because of the ratio between time expired and initial concentrations, with negative on the other side because you can't have a negative time and K is going to be a positive value. So for first order reactions, the natural log of the concentration of R at time t divided by the concentration of R at time 0 equals negative KT. Within these, if we know the concentrations at those two things and we know the value of how long it took place, like whatever the value of t is, we can calculate the value of k just by doing some relatively simple algebra. If I know my initial concentration, if I know R sub 0, and I know k, then I can solve for the concentration at time t. If k is known and the initial concentration is known, we can figure out the time elapsed in order to come up with a given concentration. So these are all just little mathematical things that we can use. We can solve for everything here. As long as I know 3 of the 4, I can solve for the one that's missing, just like a regular algebra problem. So again, the first order, the units on k are going to be 1 over time, because since these units over here are going to be time, k has to be 1 over time, because we're going to cancel those units out to come up with a number, a mathematical ratio. All right. Because those units are 1 over time, we can use just about any concentration that we would like. These are usually going to be molarity, but they could also be things like absorbance or pH, lots of other things. Like if we know what it is at the beginning and we know what it is at time t, those units are going to cancel each other out, and we can use just about anything. So now as we continue, what we're going to look at next is not just a first order reaction. We need to look and see what happens with a second order reaction. For a second order, the formula is a little bit different. The formula for a second order reaction is 1 over the concentration of R at time t minus 1 over the concentration of R initially equals positive KT. This time the units on K, K's units will be liters over moles times time. So now again with this we're looking at 1 over the concentration. There's a lot of algebra that's going on here, and especially the higher end like pre-calculus and calculus stuff. It's not really that important to understand what's going on. Just being able to recognize the formula, being able to plug numbers in, and be able to do math and solve for it. There's going to be another thing I'll talk about in just a few seconds about how we're looking at these and how we're going to know whether it's first order, second order, or even 0 order. So now that's first and second order. For 0 order, it's going to be just, again, slightly different. If it's 0 order, that means the concentration has nothing to do with the rate of our reaction. So for these, if 0 order reaction, it's going to be the concentration of R at time 0 minus the concentration of R at time t equals positive KT. And now, again, just like before, the units on K will be moles. Did I do that right? Yeah, moles per liter times time. For some reason I had a little brain bubble right there. So for 0 order, the concentration is not going to have an effect on the rate. So whatever our initial concentration is minus our time t concentration, so we're seeing the stuff's going down, it's not going to affect what's going on. It's basically KT, and we're just looking at how fast the stuff's going away. It's 0 order. It's going to be based on the value of K for a given amount of time. How much stuff went away, what's going on. So now, all of this means what? That this rate loss stuff can be plotted on a graph. So what has to happen is when I'm looking at a graph, I'm trying to find a straight line. So when I'm looking at this equation, the natural log, here let's rewrite all these again. So here's first order. Our first order was the natural log of R at time t divided by the concentration of R at time 0 equals negative KT. So there's our 3 different mathematical expressions. If we were to graph these on a graph, we are going to be looking for the one that is going to give us a straight line. if we know the concentration and the time, we can plot a graph in order to determine the overall order. So here's what we're looking for. We're looking for which one gives us a straight line. If we know these things, then I'm going to look for what two things on my graph are going to give me a straight line. So here we go in order. For a zero order graph, what you're going to see is that the concentration of R at time t plotted versus time is going to be a straight line. If that's a straight line, it's zero order, and the slope of the line will be a negative k. All right, negative k for our slope. If for a first order reaction, I'm going to plot the natural log of r at time t versus time, and for there we get a straight line. It'll be first order, and the slope will again be negative k. And then if it's second order is going to be 1 over the concentration of R at time t. If that gives me a straight line, I forgot to say that, if this equals a line, then it's going to be second order, and the slope of this line is the only one that's positive. The slope of that line will be positive k. All right? So again, these different things, you're going to look at a graph, and they will plot different things, and it'll look something a little bit like this. If we have our graph, it's going to be time over the concentration, well, not the concentration of natural log. We're going to look for the natural log of R at time t, and if that gives us a line, then that's going to be first order. If it is 1 over the concentration of R at time t versus time, actually I don't even think it's versus time, it's just a plot of 1 over RT, but it has to be over time. I didn't write that down properly. Something's hinky. But again, if I get this, I'll get a positive line. That's second order. And then if it is just the concentration versus time, concentration of R at times t, at time t, then that'll be zero order, and it will also look like this. All right. So what you'll end up seeing is you'll see pictures, and they'll show you a graph, and it'll be labeled with those 3 different things on the side, and you'll say which one of these is, or which order is the reaction based on the graph. So what they'll usually do is you'll see all 3 graphs plotted at one time. So it'll be something like this, and it'll say in green it's R at times t on, I messed up. Imagine that. Green is going to be R over t, and then the red is going to be the natural log of R at time t, and then the blue, or purple, whatever color this ends up being, is going to be 1 over RT. So what's going to end up happening is you don't get straight lines. So if my purple one goes like this, and my red one goes like this, that was supposed to be red. Let's try again. The red one goes like this, and then the green one goes like this. Good gracious. Green one goes like that. Then we'll know that this is going to be zero order. And depending on which graph gives you the straight line, that will tell you which order that reaction is. So with this, basically what you need to be able to do is do some of these sample problems. There's a bunch of them in your textbook. I will give you a few of these later on. Like I will come up with answer keys and post them here on Moodle. But basically, in order to know how to do these, you're looking at the end of chapter 14, you're looking at numbers 7, 8, 9, 11 and 12, 15, and 19. So if you look at those, I will put up an answer key to these sometime this week, probably either Tuesday night or Wednesday during the day sometime, and then we'll be able to see how to do those. There's one more thing that we need to talk about with these integrated rate laws. We'll talk about that hopefully in class on Wednesday or Friday, depending on if we have enough time. Again, Tuesday in class we did the lab, so this was in order to give you some instruction so that when we can use time in class to do labs, you can still get notes from me. I think this is a beneficial way of doing things, and we'll continue this way. All right, see you in class.